Okay, so we're going to expand what we just learned about cycloaddition. So we have seen the 4+2 system, right? We call Diels-Sauter reaction. Now we're going to go over 2+2 or some other type of reaction. And we're going to use the frontier orbital theory to explain in this reaction should expect to be working or not. Okay. All right, we're going to take a look at the 2+2. Okay. 2+2 mean one molecule use 2 pi electrons. The other molecule also use 2 pi electrons. So 2+2. Okay, Diels-Sauter will do 4+2. All right, using frontier orbital theory, we look at HOMO of the nucleophile and the LUMO of the electrophile, and they overlap. Okay, so basically, one ethylene gonna be the nucleophile, the other one's gonna be the electrophile. One of them gonna use HOMO, the other one gonna use LUMO. Okay. All right, let's take a look at one ethylene. Let's say we start with ethylene on the left side, and we pretend that this guy's a nucleophile. All right, where's the LUMO? First off, you can draw the molecular orbitals. It will look like this. So at the bottom, so all the phase goes up, right? No nodes. Go one energy level up and down, one node. Okay. All right, now let's fill up electrons. How many pi electrons are there in one ethylene molecule? Just pi electrons. 2. Right, so with 2, one in one p orbital, the other one in the other p orbitals. In molecular orbital, put this guy together up and down. We start filling from the bottom. Right? Remember that? All right. So where's the HOMO? Right here. That's a HOMO. This guy. Okay. All right. The other ethylene, we're going to pretend that this guy will act as an electrophile. All right. So we are interested in the LUMO of the electrophile. What's the LUMO of ethylene look like? Well, I mean, it's going to be the same thing, right? Ethylene on the left side, ethylene on the right side, identical, so the same thing. 2 electrons in an atomic orbital, and 2 electrons down here for molecular orbital. So this is HOMO, and next one is HOMO, LUMO, right there. Basically, if these 2 ethylenes were to react, HOMO and LUMO will overlap. Okay, there'll be overlap between HOMO and this LUMO. Now, tell me though, look at the faces of all these 4 orbitals. Do they match though? Do they have the same color? You can say like on the left side, yeah, but on the right side, no. Okay, basically, the molecular orbital predicts that if this reaction were to happen, the bond right here will be held by just 1 electron. The other electrons, there's no electron right here. Okay, so it's highly unstable. You know, a bond consists of 2 electrons, but right now just 1 electron. It's unstable, so we call this symmetry forbidden. So we predict that this reaction won't occur under heat. We call thermal reaction. So heat right there, thermal doesn't occur. However, if we do if we run this reaction under light, this would happen. Remember what happened if you add light? Well, 1 electron would get excited to the next energy level, and the HOMO changes from the bottom to the top to the pi 1 star. That's the HOMO. The LUMO doesn't change, stay the same. Okay, so in under this condition, this HOMO will overlap with this LUMO. What do you think? Do you think that the phases do they have the same phase? Exactly. All right, so that look like more stable now. All right, so we have a technical term we call symmetry allowed. All right, summary. What we just learned. Well, the 2+2 cycloaddition of the 2 ethylenes from molecular orbital theory, thermal doesn't work. All right, so the molecular orbital explained that we have to do photochemical reaction or run this reaction under light. Okay, now let's see if you get what I just said. I want you to do this on your own and check with me on the next video. But before we start, all right, let's read together real quick. I'm just going to guide you through it. Use frontier orbital theory to predict if 4+4, so we have 4 pi system, react with 4 pi system. 4+4 cycloaddition would work under thermal or photochemical. So it asks you if you want to do this reaction, light or heat. Okay, and what are we interested in? Well, these 2 react. One of them going to be a nucleophile, the other one going to be electrophile. For the nucleophile, we're interested in the HOMO. What's it look like? Okay. For the electrophile, let's pretend this guy's the electrophile. We're interested in LUMO. So basically, you're gonna go figure out what's the HOMO look like and what's the HOMO look like, and can they overlap? They need to have the same phase. All right, and that's all I can say. All right, let's check with me on the next video.